Okay, so in this video I'm going to run through how to name and draw organic molecules. It's actually quite a straightforward process. First thing you're going to do is count the number of carbons in your molecule. So I've got 2 carbons here, and that tells me that the name begins with ETH. I then look for my functional group. This is a carboxylic acid, and because I've got a carboxylic acid, it ends in anoic acid. The next one, same process applies. I count my carbons. I've got 1. That means it begins with METH. And this time I've only got 1 oxygen. This is an alcohol. And if it's an alcohol, it ends in anol, methanol. Next one, I haven't drawn it out, but the same process applies. I've got 1, 2, 3, 4 carbons. So it's going to begin with BUT. And I don't have any oxygens, which means it cannot be an alcohol and it cannot be a carboxylic acid. It's just a hydrocarbon, so it must be an alkane or an alkene. Now you can draw this out in full to see if there's a double bonds and see if it's an alkene, but your other option is just see which general formula it fits. So there's 4 carbons. If I count up the hydrogens, I see I've got 10, and C4H10 fits the general formula of an alkane. I've got double the hydrogens plus 2. Therefore it must be butane. The next one, again, I haven't drawn it out, but there's just 1 carbon, so I know it must begin with METH. This time I do have oxygens, and because there are 2 oxygens, it's a carboxylic acid, and the name will end in anoic acid. The next one I've drawn just slightly weirdly. Same process applies though. 3 carbons this time, so it's going to be prop, P-R-O-P. I do have an alcohol group this time, just 1 oxygen, not 2, so it's alcohol, not carboxylic acid, and it means it will end in anol. That's sorry, CH2OH, so it's propanol. The next one, another hydrocarbon. It must be an alkane or an alkene. 3 carbons total, so begins with prop. And again, if I look at my general formula, I've got 3 carbons and I've got 6 hydrogens, and that fits the general formula of an alkene because I've got exactly double, and that means this must be propene. But again, if you don't like doing it that way, just draw the molecule out in full like I've done down here. So I can see that there's 1 carbon with 2 hydrogens, then a carbon with 1 hydrogen, then a carbon with 3 hydrogens, and I can clearly see that even though I've drawn all the atoms, not every carbon has 4 bonds. There must therefore be a double bond, and I can see now clearly that it's propene. When you are naming alkenes, you sometimes need to include a number. With propene, you don't, for the simple reason that if I move this double bond and I draw it like this instead, it's actually exactly the same molecule. If you took this molecule and flipped it 180 degrees, it would be this molecule here. And because these molecules obviously don't exist in 2D on a piece of paper, they're 3D structures that can move around freely, it's totally feasible for a molecule to just flip 180 degrees. And these two are exactly the same thing, and they would both be called propene. But when we get to the example below, where I've got 4 carbons, first example here, I've got the double bond at the very end. I can take this, I can flip it over, and I will get this molecule next to it. It will be exactly the same thing. But for my final molecule, you can see the double bonds in the middle of the chain, not on the end of the chain. And there's no way I can flip or rotate either of these molecules that will get me to the molecule on the end. So this one here is different, and it needs to be reflected in the name. So I'm naming these. They've all got 4 carbons, so they're all going to begin with BUT. They're all alkenes, so they're all going to end in ENE. But to tell the difference between them, I number where the double bond is. Here, it's on the end of the chain, so I label this but1ene. Here, it might be on the right-hand side, but it's still the end of the chain. It's still but1ene. I can get from this molecule to this molecule by just flipping it over. This molecule is unique. It needs a different name, and because the double bond now starts in carbon number 2, it becomes but2ene. Other thing you might be asked to do is draw. So if they give you a name, they might ask you to draw. All right, so we'll do the first one here, propanoic acid. Because it's prop, I know I need to draw 3 carbons. Because it's anoic acid, I know it's a carboxylic acid. Now the carboxylic acid functional group must be on the end of the chain. It's either on the left or on the right. I'm going to put it on the right this time. So C double bond O, single bond O, and then a H. So the double bond O and the single bond OH are all on the same carbon. You'll see that there's 1, 2, 3 bonds coming off carbon from the functional group. The middle carbon already has 2 bonds, so I couldn't put a double bond O and then a single bond OH. There's not enough space. That's why the carboxylic acid group always has to go on the end of the chain. If you wanted to put it on the left hand side, you can, but just bear in mind that if you're putting it on the left hand side, you need to flip that OH and write it as HO to show clearly that carbon is bonded to oxygen, not bonded to hydrogen. So just make sure that's clear that the carbon is bonded to 2 oxygens. You'll write it as HO if you draw it out to the left. The next one is ethanol. Because it's Eth, it means there's 2 carbons. Anol means there's an alcohol group. That's just the OH. I can put the alcohol group anywhere I want. It can point up, point down, to the left, to the right. If I go here to the left again I need to remember that it's HO and the carbon has to be bonded to the oxygen. I then fill in my hydrogens, and I really should be showing the bond between that oxygen and hydrogen as well. The next one, propene, 3 carbons because it's prop. Ene means it's an alkene. Now, if you were given this as C3H6, often what students try and do is they try and fill in the hydrogens before they put in the double bond, and they usually distribute the hydrogens evenly and go 2, 2 and 2. Don't do that. Always draw your functional group first. So draw the atoms, then draw your functional group. If it's ene, I know it's an alkene. I put that double bond in, doesn't matter where, and then when I'm filling in my hydrogens, I can see that they're not evenly distributed. It actually goes 2, 1, 3 because that's the way to give carbon 4 bonds each. The last one, butene, again same process, it's buth, so I'm drawing 4 carbons. 2-ene tells me that the double bond has to be on carbon 2, and then I'm filling in my hydrogens. I'm going to have 3 here, 1, 1 and 3. So again, by putting that functional group in first, you'll then be able to distribute your hydrogens.